Quirin Scheitle. He's a third-year PhD student at EU Munich, and he's interested on large-scale measurements with a focus on security-related questions. And he's going to talk about some TLS analysis.
Thank you a lot. Hi everyone, really happy to be here. I'll present this piece of work which I've done with Matthias and Quirin, and I really hope you enjoy it. Basically, where we started off is we said TLS 1.2, your handshake does not encrypt certificates, and this has been known for a long time. It's been discussed in the community. It's kind of a known weakness. Now, if you think about it, for servers, that means eavesdroppers can know which website you visit and some things like that, which is semi-private, but for client certificates, I mean, governments use them to register their voters. In some countries, there's names in there, there's all kind of stuff in there. Now, going further, we looked at where is this used, and it's used in authentication of networks, in VPNs, in HTTPS, in some upcoming IoT protocol. It's used for remote management, like if companies do this bring your own device, iPhone thing, these typically also use that. And interestingly, in Apple push notification service. And if you quickly look at Apple, it has 1 billion active devices, which is massive, according to some source 2016, and a lot of iTunes accounts, which also use it. And a quick brief on push notification services themselves. So I think it came to existence as kind of an energy-saving thing, where you say all those apps don't have to pull all their servers, but they just subscribe to this push notification service and then get notifications if something happens that they should know. And Apple, Google, and Windows all run these, so every major platform has it. Firefox even has it integrated by now. If you like some flight pages, use it to remind you that some timeout is happening or something. The thing is, this is very tightly integrated into your operating system, so unless you've, I don't know, blacklisted DNS or whatever heck, all your Macs will at this point be connected to this service. And also all your iPhones. And this is kind of critical because it is always on. It is per definition always on. You're always connected to that service. So whenever you connect to a network, this logs into this backend service. And they use client certificates, and these are unique. So they are generated at device setup with a timestamp precise to the second. They have a public key, which is very long and unique. They have a common name, a subject, a serial number. Great for tracking devices. So you have really unique information, and it's transmitted basically all the time. So here we look at user tracking, and I must say really the certificate, it belongs to the device, but I carry this phone all the time, so it is kind of reasonable to correlate it to users and say this device typically matches to this user. Now if we look at this from a security perspective, kind of 4 attacker models come to mind, but we only look at 2. So obviously if you're Apple or someone infiltrating Apple, you have better means to track all your users. You don't have to do it. Also, if you kind of run this Wi-Fi hotspot, you can look at MAC addresses or other things. But the interesting thing is, if you're kind of a regional ISP and you might want to track your users, or if you're a global adversary and you say you want to track users on a global scale and you would need access to some big networks, but then you could track a lot of users very precisely. So what we did is we validated a regional adversary at a regional internet uplink, and we validated a global adversary through global path measurements and identifying where are those backend servers and how do people connect to them. And I'll first take you through the regional validation that we did using passive measurements. So we captured 2 weeks of CCA traffic, we filtered for the APNS ports, and only for the part in the TLS handshake where the certificate is sent, basically to save data. And we saved timestamp, 5 tuple, the certificates, and some TLS extensions, and then crawl through the data. But before we do that, we have to go through these ethical considerations. What are we doing? Is this harming users? Because we are working on real human subjects. So we have IRB regulations, which say, before you do anything, document it. Isolated measurement infrastructure, only certain people may access it. You must not copy the raw data anywhere. I guess that's kind of standard procedure. And also we restricted ourselves to say we will not try to identify actual users, so we will not try to map those certificates to real users, which might probably be possible in many cases. and we will not publish any identifiable data, which is also, I guess, a reasonable baseline. So now if we look at all these logins that we've captured, the bulk majority is Apple, and 56,000 certificates in 2 weeks, that's a lot. That's really a lot. So if you do like HTTPS, TLS capturing, we would see 200,000 server certificates. So this is really quite a lot. And then there's some small baseline of VPN and stuff, but we only captured 443 and some APNS ports. So if you would look at port 1194, OpenVPN or stuff, you would probably catch a lot more of these certificates. But clearly, APNS is the bulk in that case. Now we looked at, can we actually track a user? As we said, we don't want to track any user, but this specific user was me, so I was informed, I was consenting, I said, okay, let's see what this laptop, actually this one here, does in our data. So I got a certificate for this machine, and I have ground truth, right? I have my calendar, I know when I was there. And I can see when did I come to work, when did I sit down at my desk, when did I use Wi-Fi or VPN, and I know that because the university kind of, you see if it's an eduroam IP, it's in a DNS string, right? So you can quite easily map that. So this was kind of the proof of concept that you can track a device / user. It definitely works. There's no kind of obfuscation or something that would make it impossible. So next question was, how many users would we be able to track? So we counted the certificates and said on how many days did we see that certificate. And it's your definition, you can apply whatever you want. We said kind of, if we see it on more than 3 days, which we do more than 50%, you can kind of track it. These might be short-term visitors or whatever, but a lot of people were really visible on a lot of days. And these you can really track and do the kind of thing that we did in the previous slide. So another interesting thing that we found, and this I really like, is if you look at the not valid before in the certificate, because the certificate is generated when you first turn up the device and registered with Apple. So if you look at those timestamps, you can tell when the device was bought and first turned on. And you see mobile certificates, it started a bit earlier, desktop a bit later. But you see those clear patterns. It's not a straight line, right? You have some chunks. And these are the Apple product releases. So every year in October, they do this thing. There's a new range of products, and then people buy these new products. And then you have an uptick in products. So you can probably tell, yes, that's probably the new iPhone or whatever. Also, which I just realized recently, at year end there's small peaks, so probably people get new stuff for Christmas or something. But you can see it in the trend. It's really interesting to see that, and it's really at second level, so we can really tell when was the device bought and turned on. So that was also quite interesting to say. We can actually give a reasonable estimate about the device type. So we next turn to, can we do this at a global scale? Can we really track users globally? And that's quite an interesting and important question, I believe. So how did we do this? And I guess it relates to a lot of what Steve told us before, how he did things. We did global measurements. First, we resolved all the DNS stuff using Web Atlas and got all the IP addresses that Apple uses, and it's quite a lot. They have a /8 for this purpose. And then we just picked the /24 subnets, did trace routes to those, and then we mapped those trace routes, the routers on the paths, to networks. So we mapped it to ISPs and IXPs, and then we count what percentage of routes that go through some certain ISP or IXP, which we would call a network in that context. And anyone who has done that kind of study before, it's not surprising, right? The internet is still quite centric. It will go through some big nodes. And what we found, we did it globally and at a nation scale level. If you pick the 10 right networks, you'll have more than 80% of user logins, basically. You'll have level 3, 25%, Telia, another 15. So it nicely adds up. And let's say if you're a very powerful attacker and you get those 10, you can track 84% of Apple users. If you do it in a country, I mean, Germany has 2 big IXPs, but most countries have big IXPs today. Argentina, I heard, most of the traffic goes through that one single IXP, so probably the first line would be 80% or something. So this is really a problem, we believe. Based on that data, we can say, actually, this is feasible, it's exploitable, and it is a problem. I have to take a note here. So we counted basically each trace from a right atlas node as a user. Now right atlas probes distribution. Let's say it's a first order approximate of where the users sit, but it's not precise. It had some biases, some ASs have way more probes than the user share. So this is one of the things where we might do a more proper version to get a good second order and more precise measurement of how do the probes map to users. But I don't think it will change the answer that 10 big networks will be the majority of users that you could intercept. Now, what did we do next? We went to Apple and said, maybe you think it's a problem. And the nice thing is we had the paper written up. So we didn't send them some 3 lines of text, we sent them the full paper. And like 2 or 3 days later, we were on a call with them, with several engineers, and they really fixed this really quick, which I was quite positively surprised, because they could have said, it's no remote execution, it's whatever, just an academic privacy thing. But they really worked on this and fixed it, and it's included in the January 2017 patches. So if you're late on updates, please do them. But it's been out for a while. They also had to patch the backend and also all the iTunes on Windows installations, which, because on iTunes, on Windows it uses S-Channel, a Microsoft TLS implementation, which Apple couldn't just end-to-end fix, but had to do a bit more. And I think that also adds to, I guess we all believe in the value of internet measurements, but some people are skeptical. And I think this shows that it really has a value, because that point of TLS 1.2 certificates not being encrypted, it's been around in the community for a couple of years, and people have discussed it, but RFCs expired, and Apple still decided to use it. So you can't really say it's been known and that wouldn't have any impact. So we believe that by us sending this to Apple, saying this is the problem, this is the impact, this is the proof of how it can be exploited, we really help them to see, yes, this is a problem, because I guess they get hundreds of emails a day with potential problems, and to prioritize it. And what we can also now do is we can actually track the progress, right? We can do that a year later and say how many people are still using old versions. So that, I think, is also a benefit that you can add here. And yeah, the good thing is also TLS 1.3 goes the right direction. It will encrypt certificates, but it's still not quite out the door yet, right? I think people are starting to add version 18 into the standards, but then some middle boxes hang up, and it will take a while before it's really rolled out. And another topic I'm passionate about is reproducibility. So what we aim for is for this to be repeatable, replicable, and reproducible, which is defined by ACM. Repeatable, so what I did is once you prepare the camera-ready version, you go through your code again. You see, can I actually do this again myself? And then pack up a nice bundle for others to use. And that way I can say, yes, I can repeat it. I can run my own stuff and I get the same numbers. But then you also provide replicability. That's why we give you the artifacts. We say, this is the code, the data, everything you need to actually produce the same thing using my scripts, but your brain logic fingers to make sure it works. And then what we hope for is reproducibility. A different team using a different method really confirming this, not just rerunning our stuff, but doing it in a different way and confirming the problem itself. And for that, we give you the detailed documentation, because you have to know kind of which PCAP filter did I use. Did I use these ports or those? I mean, you need to know some details. And these are maybe not all in the paper, but definitely all on GitHub. Another really fun thing we did, and all the PhD school attendants know it, we ran an exercise at the PhD school where we did the RIPE Atlas lab and said, let's reproduce the RIPE Atlas part of the paper. And people could, step for step, kind of go through the paper, research question, measurement strategy, do it and see if you get the same result. We didn't quite finish, but at least we got started. And that's also public, you can have a look. Good, another thing I want to touch, obviously there's a lot of private data in this, so we cannot give you the raw data, it's just way too private. But what we can do is we can cut up the pipeline and put anonymous data in. So we anonymize it, and you get the script how we anonymized it, so you know we didn't just invent something. And then we feed it in and put it on GitHub. So actually, if you click any figure in the paper, it will take you to GitHub, right to that script that created the figure. And you can see the figure there and how it was created in the full pipeline, except it's anonymous. So for example, for that run-up of dates, I just put it on day scale, so it will be a bit more edgy, but it will look the same. For the active measurement, that's easy. It's on RIPE Atlas. Everything is public on RIPE Atlas. We give you the measurement IDs, the script, the code. You can rerun the full thing and also use the lab from the school as an example of how to run through it. Good. Where do we take it in the future? So, as I discussed, measuring the uptake will be interesting to say how quickly does this get used, this new version at Apple Pulse. Also, looking a bit more in detail at the APNS backend infrastructure, like where are their clusters, because it's actually quite a big service. They get billions of logins a day, and they have to serve that. So I guess it will be quite interesting to look at that in more detail, and also do that control for AS population versus RIPE Atlas probe distribution, which is not one-to-one, will be quite interesting. Good. Key messages. CCA does send certificates unencrypted. Please really think twice before you use it in TLS 1.2, especially if you have that always-on mobile scenario where devices are constantly logged in. That's really not the best. And yeah, we quantified it, sent it to Apple, and they actually fixed it, which I'm really happy about. Data and code is both on GitHub. The data's not too big, so we can actually just host it on GitHub. And that's the end of my talk. I'll be happy to answer questions.
No question. Thank you. You get the best citizenship paper award on that one. Seriously. I mean, I'm biased, of course, but no, seriously.
Yeah, great stuff. You mentioned the user /8 for this push.apple.com domain thingy, is that correct?
Yeah, 17/8.
So that's a V4 only thing?
Yeah, only
I
V4.
thought Apple was quite V6 minded nowadays, but that's not the case.
Not for that service. I mean, we double checked, they don't use V6.
Okay, so that's a reason to use V6 then as well, right?
Yeah.
When you say Apple fixed promptly, they just encrypt certificates, they do something in the back end?
Yeah, they never really told us what they changed. We can confirm they do not use this anymore. We believe they do it similar to Google or Windows, that they just have some kind of authentication in the encrypted layer. Maybe HTTP, HT access. We can't see it anymore, it's encrypted. Yeah. But it's not CCA anymore.
Have you thought about how that kind of analysis that, if you capture 10 networks, you get this kind of information might impact on things like identifiers and new protocols like Quick?
Sorry.
So I think an interesting part of this is that you were kind of saying that if these identifiers are detectable and you get 10 networks, you can get 80% of people identified. Have you kind of looked for other similar identifiers in, for example, Quick or?
Yeah. We thought about it. We couldn't come up with a quick other thing to look at. Maybe Quick is one thing that uses those. I'm not that familiar with Quick.
But it's just that there's currently debate about what identifiers to leave visible to the network. So it would be really timely if you were interested in looking at that.
Yeah, it's a good hint. Thank you. For anyone else to take it up.
Any other question?
Did you had started with a list of protocols that use client certificates? Have you gone and targeted any others to see whether you can get a similar kind of result?
No, they are all up for taking.
Okay.
I believe it will be similar. I emailed some like OpenVPN and Mobile Iron, but I never got a reply from all of them. So I guess they're still vulnerable, so to say.
Another question? I would like to ask you, how was the interaction with Apple?
Really positive, yeah. So I was really surprised. They really took it serious, and we always had these calls every week, which was kind of a bit too much for me even. And they typically had 3 to 5 people. We never got their full names. They were all like Scotty and Scott and but yeah, and we got to test their betas and stuff. It was really, really nice. So I think they really take it seriously, the security and privacy.
Another question? Okay, so let's thank Quirin again.